Hi, my name is Ashlee Prejean, and today I'll be talking about how varroa destructors cause colony loss in honeybees or Apis mellifera hives during the winter months and how to prevent this. During the winter, there's typically elevated winter losses of honeybee colonies. It is naturally a more difficult time for honeybees to exist during the winter. This is because during the winter, honeybees must stay warm and they need food to survive. So they typically get their food during the summer and warmer months and store up for the winter. So if they run out of food, then they're going to starve. And staying warm requires food and energy in the form of honey. And if the colony exhausts its supply of honey, it's going to freeze to death before the spring. This causes approximately 30 to 40% of colonies lost around in Europe, United States, and Canada. And in the United States, there was a reduction of approximately 1.5% of colony losses in the United States. And it was originally a decrease of 0.06 a year before the introduction of varroa destructors. And this being said, a big factor contributing to the loss of honey hives in the United States is actually the infection of varroa destructors. Varroa destructors are actually, another name for them is varroa mites, and they are a red-brown external parasite that latches on to the honeybees when they're out foraging for pollen to bring back to the hive. You can actually see one on the picture I have provided to the left of the screen. You can see the little red-brown tick-looking parasite that has latched itself onto the honeybee and will then be transported back to the hive unless the bee dies on the way there, because varroa destructors will typically eat the fat from the drone and worker honeybees that it latches onto. So most of the time they will die before they will even come back to the hive, which then reduces the amount of pollen coming back to the hive, which reduces their food supply. But if they do go back to the hive, they can actually affect the whole hive and more specifically the larva. And this causes them to feed off the larva, which then causes malformation and weakening. And so when they grow older, their lifespan is then shortened because they're not as strong as the uninfected bees in the hive. If a honeybee is infected by a varroa destructor, it can cause scattered brood, crippling or crawling honeybees, impaired flight performance, or wing deformities. Can also cause a lower rate of return to the colony after foraging if they die along the way, a reduced lifespan, and a significantly reduced weight of worker bees. Varroa destructors can also carry other viruses, and when they are brought back to the hive, they will infect the whole hive and can cause colony collapse disorder, or just colony collapse is in general. As I stated earlier, we can see the honeybee population naturally decreases in the winter, even without the help of varroa destructors. But as we can see in the graph to the right, the varroa destructor population actually rises in the winter. So there is an increase in varroa destructors that latch onto the honeybees that bring back to the hive and then infect everything else and shorten the lifespan of individual bees and therefore shortens the lifespan of the hive altogether. Possible treatments to decrease the infection of Varroa destructors is actually treating the hives with archaicide. To the right is a graph showing the prediction of what the scientists believe would happen if they treated the different hives with archaicide during different months of the summer. So they treated a hive in July, and August, and September, and did their expectations of how the population of the beehive would be after the winter months. And it's expected to work better in earlier months than if they had applied it during later months. In conclusion, we can conclude that Varroa destructors are a significant cause for declining in bee populations in the winter, especially in the United States. And archaicide treatments in earlier summer months actually increase the survival during the winter months by allowing stronger winter bees to form, which then expands the life of the bees in the colony. It can also induce resistance and tolerance that can occur naturally and even with the help of scientists with these treatments. The significance of this research raises awareness on declining bee populations and their causes, as if our bee population continues to decline, it will have tremendous environmental factors that will impair agriculture and just our way of life in general. Beekeepers also need to be aware of Varroa destructors, and they need to be held accountable for their hives, and maybe even thinking about implementing these treatments in their hives to decrease the amount of Varroa destructors. Fighting off Varroa destructors can honestly be the key to increasing honeybee populations all around the world, not just in the United States, which of course we need in order to sustain life as we know. Here are my resources, and thank you for your time.